Hello and welcome to our VAST customer training webinar. This month we are talking about mastering S3 on setup and configuration on VAST Data Platform. My name is Kristen Thompson. I'm Director of Customer Education here with VAST. And just a few pointers as we get started. We will be sharing a PDF of the deck during the presentation. We do have a read-only lab environment. If you want to log in and click around, you'll be able to do that. All that's required is any email address to be able to join. So I'll put the link for that as well. In addition to today's webinar, we do have an on-demand learning portal that you can access. I'll put the link for that in case you're not in there yet. We'd love to see you in there with full admin training and links to all the different webinars. We also have a YouTube playlist that includes webinar recordings. We'll put the link to that as well. With that, I will just say that we have a very exciting webinar, and we have a Q&A little section. If you want to enter any questions in there, we have a team who will be able to jump in and respond to those. And now I'm going to invite to the stage Phil Wagstrom from the Office of the CTO. He is your presenter for today. And Phil, welcome. I am just going to let you dive right into this topic.
Good morning, Kristen. Thanks for the introduction, and we'll get started here. So I'm Phil Wagstrom, the Office of CTO here at VAST. I do responsible for multi-tenancy, multi-protocol discussions here. So today we're going to be talking about S3, how you go through and how you set up S3, how it's implemented on the VAST data platform, and go through some of the basics for this. There's lots of additional features with that, but this is going to stick mostly with the basics on how to get things up and running with that. So with that, let's get started. I'm going to go through and share out my screen, and we will dive right in here. Hold on just a moment. All right. So let's dig in here, and we are going to go through and talk about S3 setup and configuration. So the topics we're going to cover is just a quick review of protocols, views, and view policies, how we go through and set these up, what those terms mean. We're going to talk about user and access keys. We're going to talk about identity policies and bucket policies and how those are implemented on VAST. We'll touch a bit on lifecycle management, and then end with some multi-protocol considerations for things, and talk about what the impact is or what the different options are for that. So first off, let's start initially with what is a view and what is a view policy. Well, a view in VAST is kind of the what data are you presenting out. Within VAST, rather than calling things an S3 bucket or an NFS export or an S3 or a SMB share, we use the generic term of a view to mean any one of those. A view within VAST exposes a portion of the element store to through set protocols to the clients on the system. Along with that, we have a view policy. The view policy is more of the how. How do we want to control who has access to this? What are the rules? What kind of permissioning model do you want to use? What VIP pools or what IP addresses on the VAST cluster do you want to expose this data on? What kind of logging do you want to do for auditing and things like that? So there's two different portions of things, and when we talk about creating the initial buckets, we'll touch on each one of these. So within VAST here, again, kind of a review here of things, is that within the VAST platform, we have what's referred to as the element store. The element store is basically where all the data is stored. For this. With our DAYS architecture, our disaggregated share everything architecture, we separate the CNOs or the front end protocol from the back end storage. For this, the element store is effectively the back end storage. It is designed to be multi-protocol from the get-go. Anything that gets stored within the element store is stored in a protocol independent format, and we set up things called security flavors to determine what kind of permissioning model that we wish to go through and use. On the front end here, all the protocols that we have within VAST, whether it be NFS v3, SMB, S3, NVMe over TCP, Kafka, database, all of those are just strictly protocols to access the element store. These are all equal first-class citizens. So we don't make use of any kind of gateways or channel data. Each one of these are first-class citizen, and they will perform as equally performing. In the back end here, within the element store, again, as I mentioned, all the data is stored in a protocol-independent format using the security flavors to determine the kind of permissioning model. But the data on all the data that we store is metadata rich. So we can go through and do some things that other platforms aren't able to go through and do, like be able to write data over NFS and let's say tag it with S3, put some S3 tags over it, or read data over S3 and write over NFS, or vice versa, or do some other combinations here, which we'll talk about towards the end here with some multi-protocol considerations. So first off, let's just walk through some basics on how do we go through and create an S3 bucket. Okay, again, this is going to be very, very simple. What are the steps to go through and start out with creating just your generic S3 bucket on the Vast data platform? So first off, when we go through, all of this is set within the element store. So on the Vast cluster, we would go navigate within the GUI into the element store. And first off, we need to create a view policy. Again, with a view policy defines the behavior. If we want to match the rules of your typical S3 bucket, where your permissions are governed by identity policies and use S3 ACLs and use all the native S3 commands to control access, we need to go through and use what's known as an S3 native security flavor. So when we go through and create the view policy, we navigate to element store, view policies, create new view policy. If we're using multi-tenancy, we need to define the tenant. So in the case here, this example shows we're doing the default tenant. For that, we need to provide a name of this view policy, because this view policy will be applied to multiple views. And we select S3 as the S3 native as the security flavor. Now, we do have options here to control for any views that we create using this security flavor, how these are presented out based on the VIP pools here in this little drop-down menu here. If I click the drop-down, I would see all the VIP pools that are defined for this. If I leave it blank, that means any VIP pool, any buckets that I create, any views that I create using this are going to be presented out across all of the VIP pools available to that tenant. But if I want to restrict it, so I'm just using one set of IP addresses, one VIP pool, we can definitely do that. We just select the individual VIP pool in there. So, or the multiples of VIP pools that we wish to go through and use. Now, there's a couple other things that we need to go through and consider. If we want to go through and restrict outside of something that's outside of normal of default S3 commands, we can restrict within the view policy access to these buckets based on client IP address. This is set within the policy. Normally, we would leave it set as effectively open, or read write equals an asterisk for all clients. But if for some reason we really wanted to restrict this only to a certain set of clients, a certain subnet, we could put those in there for this, or limit things only to read-only. And again, this is really more of a convenience factor. It's not defined within the S3 protocol for these controls. It's defined within the view policy. So it's similar to setting like a read-write or a read-only for your NFS exports. We can put in here individual IP addresses. We can put IP address ranges. We can put subnets. If we're running VAST 5.2 or later, we can use FQDN host names in these entries, or put net groups in here as well. Some additional ones here, even though we may intend this not to be used over NFS, we possibly might eventually want to do things over NFS for this same view, or access this data over NFS, because again, we are multi-protocol. So there are some other options here that we need to go through and specify. Specifically, this group membership source is a required item to put in here. And what this does is that it for clients that might access the same data over NFS, for here we're going to set up just for S3, but for those that want to access it over NFS, this talks about how do we want to handle the 16 group limit with that. Do we want to rely just what the client sends for NFS, or do we want to go through and look up the user and get all of their group membership from the providers like Active Directory or LDAP? And there's a couple other options related to NFS specifically, but generally, if you're looking at just an S3 bucket here, you still have to specify this group membership source. The recommendation is set it to providers, because we're going to go through and get things from that. If you're not using NFS, you're not going to be sharing this data set out over NFS. It doesn't matter much, but we still need to specify a value here. Once that's done, we could go through and click create on this, and then we would have an S3 bucket ready to go through and do. Now, there are some other options here we can set in the view policy, and I'll talk about those briefly, is that what these are, let's say we want to give some additional rights here. So if we are looking to allow for bucket listing permissions for specific users or specific groups, meaning this user would be able to at least list all the buckets, by default, you're only able to see the buckets that you own. By putting entries in here for either specific users or groups of users within VAST, this would allow users to go through and list buckets that they didn't necessarily create. They would be able to see ones there that were created by other users or owned by other users as well. There's also option here where it says, use for new S3 buckets. What this means here, and we'll talk about this in a second, is that if we're going to use this for an S3 endpoint rather than an S3 bucket, this is the policy that's going to be attached for those new buckets that get created. It'll use this policy to apply for those new buckets when things get created, under an S3 endpoint. There is also options here to allow for enable S3 special character support. So by default, because VAST is multi-protocol, we do by default set up what we call a least common denominator, or LCD, style when it comes to approaching file names and object names. That's the default setting. So what that means is that there's certain character sequences, especially around S3, because S3 for a bucket is going to be a flat namespace. It doesn't have the concept of directories. So you could create S3 objects that have dot dot or slash dot dot slash as part of the object name, and that's valid for S3, but it doesn't necessarily apply to NFS or things there. So by default, we don't, when we set up the view policies to maintain that compatibility across all, we don't initially allow that. If you want to make an S3 only bucket and you want to be able to use those types of character names in there, then you would need to go through and toggle this S3 character support setting in here. It doesn't affect anything else. It just means that, okay, we're going to be able to create objects there. If eventually you do want to have things shared out over NFS or SMB as well, just be aware is that we don't support name mangling for this. So if you do have objects that get put up there with some of these character sequences that are not valid for file access, those objects will not be visible for that. There's some other options here related to multi-protocol where it talks about how do I want to use or do I want to allow the full path in an identity policy. This is more for cross-protocol type situations there. Generally, your identity policies are only support the bucket name and possibly some prefix. This will allow it to be evaluated for multi-protocol access in there. And then there's also other options in here that allows listings of objects based on identity policies as well. So this again is going to apply to multi-protocol more than anything else. So once that's but those settings there, leaving things as the default gives you a functional view policy. So moving on to creating a bucket view itself. This again is going to be very, very simple as well. So we can start out, we go into Element Store Views and say create a new view. And we get presented with our view creation screen. The view creation is we need to select the tenant that this view is going to be created in. And you need to make sure that the tenant that you select, if you are using multi-tenancy, matches the view policy that you want to use for that. View policies are assigned to tenants. Views are established within a tenant's namespace. So the view policy and the view have to be part of the same tenant for that. And then provide a path as to where this bucket is going to reside within the element store. Again, the element store does behave somewhat more like an object store, more than a traditional file system, but how we organize data, how we present data in there does use file system nomenclature there, so we need to provide a path. Now, You can have nested paths. You can put multiple delimiters there. If you want to break down the buckets by department in the path, you can go ahead and do that. So in this case here, I'm just creating a path. I'm just using a path called my/my-s3-view. This could be /department1 view1 /department2 view2 slash department1/view3 for that, however you want to go through it. It doesn't matter when we export things out over as a bucket for that, just more how we want to organize data internally. And when it comes to things, it does have some impact when we start talking about possibly wanting to establish a quota for how much data can be put in this bucket, or when we're talking about replication. But for an actual a single bucket, without considering one of those, it doesn't matter necessarily what the path is. Now, for net new buckets, we always need to go through and create a new directory for those, because the path doesn't exist on the element store, so we can create a new directory for that. If we already have data out there, maybe data that's been created through replication, or I removed a view and I want to recreate the view, and I don't need to recreate the directory, then I would leave that unchecked. But in this case here, net new views always have to create a new directory for them. Inherit ACL from parent, there's some different functionality on that. Generally, you don't need to worry about this for net new buckets. There are some rules for existing data if I want to inherit things from there, but we can generally leave that alone. Other items here we go through, we select our policy that we created. So I created the view policy of my S3 policy in the previous step. I'm going to use that policy here. If I have a QoS, I can set a QoS policy here as an option. But under protocols, then I select the protocols that I want to use here. In our case, we're just doing an S3 bucket. So I'm going to go through and just select S3 bucket as the protocol from the drop-down list. And then once that happens, I need to provide a bucket name. Now, the bucket names here can really be whatever you wish to desire. This is when I do a bucket listing. I'm going to see that bucket name there. It's going to be part of how I access it. Like other platforms like AWS, the bucket name has to be unique. Within VAST, it has to be unique within the cluster. This is different from, let's say, NFS exports or SMB shares, where the share name or the NFS export only need to be unique within the tenant. Within VAST, the S3 bucket name has to be unique across the entirety of the cluster for it. And then we have options here to say whether we wish to use S3 ACLs for this particular bucket. We can go through and set S3 ACLs. Largely in this industry, S3 ACLs are not highly used anymore for that. They're more relying on IDM or identity policies for that. You can have those here and manage those as well. But for this example, for simplicity here, if we set ACLs disabled, that will not use ACLs, and for access, controlling access is going to be controlled strictly by the identity policies for them. There's also some other things there that if we have ACLs enabled, when a user writes to a bucket, the object is going to be owned by the user doing the writing. So if you have multiple users writing to a bucket for that, the objects will be owned by the different users that actually did the object creation. With ACLs disabled, the owner of the object when it gets created, even if it was created by somebody else, is going to match the bucket owner for that. So a little pointer piece of information there. So select those options there. Once those are done, then we need to go down to some more S3 specific options here. First off, S3 always needs to have a bucket owner. A bucket, that is part of the requirement. It always needs to have a bucket owner. When you set an S3 bucket owner, as you set an S3 bucket owner, or as you enable S3 protocol, a bucket owner has to be established for this. Now, for net new buckets, net new exports, and net new things there, this isn't a problem. Goes through, it creates the bucket. The owner of the path is set to that bucket owner. And that's all good. If you have existing data that's already out there and you're adding S3 as a protocol to that, what will happen when you set the bucket owner, when you add the S3 protocol and set the bucket owner here, is that effectively a chaon will be done on the path not for anything necessarily that's in the contents of that path, but at the top of the path, a chown will be done to make the owner of that path be the bucket owner. So use with caution if you're establishing this on data that's already there and already shared out with other protocols as well, or using other security flavors. So one thing to be aware of there. There's a couple other options here in terms of how do we want to go through and handle S3. There's going to be S3 specific ones, such as, do we want to allow anonymous access? Normally with S3, you need to have an access key, access key and a secret key to access. There has to be an identity policy associated with this. This is one of the flags here that allows us to go through and create an anonymous S3 bucket. So I might be able to just do a curl against it to go through and get that data. So it's one of the items there that are available there. There's some other ones in terms of how we control some access related to that. We have options here. We do support versioning for S3. So what versioning is with S3, if you're not familiar, S3 you're not with S3 because it is an object-based. There's not editing in place of objects. When you want to change an object, you upload a new version of the object as in its entirety. If you have versioning disabled, that overwrites existing object. If you want to enable versioning, when you write a new object of the same name, that will create a new version of the object. You will always access the current version, but you can specify, I want to access an older version for this. This allows us to turn that on or off. So within the element store, this is enabled. There's options here for object lock. I'm not going to go deep. I'm not going to go into object lock and how all that works, especially around things like the retention policies. But within object lock, what this does is allows you to go through and put an object into the bucket, and then once that object hits the bucket, it will not be allowed to be deleted for a period of time defined by a policy, and there will be controls around that. So useful in certain cases. There's also options here around bucket logging and bucket notifications. Those are more complex to go through and set up a little bit beyond the scope of what we're doing here in this webinar, but you can set some other options in there. But for your general bucket here, leaving things at just what the default are, if you just want to start doing some playing around with access, this is all that's needed. You can go ahead and hit create, and the bucket will be there. It will be visible, it will be available for access for these users here. So we've got the bucket defined. We've got the view policy defined. It's there. It exists. How do we access the data now? So with S3, you have the notion of an S3 access key. This is the identifier for a user to get access into the bucket. It might be analogous to, let's say, a username password for that if you're not familiar with it, but this is what S3 uses for accessing data. S3 access keys are managed locally on the VAST cluster for users that are either defined locally or for users that exist in external providers like Active Directory or LDAP. Each cluster maintains its own set of access keys. So let's talk about how we create those. So the keys, again, are stored on the VAST cluster itself on a per user basis. We do support up to 2 keys per user. Those 2 keys per user allow you to do key rotation occasionally. So what that means, I can create a new key and delete the old key for that and still maintain my access for this. Now, again, the keys are going to be local to the cluster, but when we talk about the number of keys for a user, there's a couple, it's actually more than just 2 keys per user. The keys are stored up to 2 keys per user per tenant. So if I've got multiple tenants, I could have 2 keys for the same user. Each set of keys is going to be different in each tenant with it. We also, when we're talking about having replication peers set up within VAST for being able to facilitate things like failover or being able to facilitate things like global namespace, those keys that are maintained and defined on one VAST cluster will be replicated to another VAST cluster as part of that peering relationship as remote keys on that other VAST cluster. So if we do a failover from site A to site B or cluster 1 to cluster 2 of any particular path or any particular set of buckets, for that, we can still use the same keys even though they weren't generated there. So for any user within any particular tenant, we may have 4 keys, we may have up to 8 keys, depends on how many replication peers the cluster is involved with. But it's going to be 2 local keys that are defined and controlled by the cluster, by the local cluster, and then up to 2 keys that are defined on a remote cluster. Because you could have 2 clusters that are both active for different buckets with different different keys for what you're doing there. So there may be a few different keys there. But when we want to go through, we want to create a key for a user, we need to go through and first off locate the user. Now, things have changed between the 5.2 version and the 5.3 version. 5.2 didn't have some enforcement around, or it was a little difficult to understand in terms of local users, meaning a locally defined cluster in terms of how things were displayed and which tenant we were working on. So there was some confusion with 5.2. It's a little bit easier, some more enforcement on how we define our keys. Regardless whether we're doing things on VAST 5.1, 5.2, 5.3, or the upcoming 5.4, the behavior here, the way the key should be assigned is this general process here, where we need to go to user management, users, we need to click up here and say query user and search for the user that we are looking for. When we search for the user, we query for the user, we need to provide a tenant. We need to determine which provider we're looking into, or look at the aggregator, which means we're going to get it from any of the providers associated with the tenant. And we need to look for the user either based on username or Windows SID or UID number. Any one of those can be used. We query for that. We get a response back for a user. In this case, I've searched for the VAST user 1. I get a response back. I click on edit, and then we're able to go through and assign a key to the user. So we'll see here on this user details screen that it tells us the tenant that we are part of, the identities for the user, and I can go through and I can click on add another key or create a key, and I will see here, this is going to be the access key for that user. This will be the secret key for that user. These are the only times that the secret key will be displayed. So you'll copy these off and provide those into whatever tool you're using for S3 access, and those will be associated with that particular user. You can also go through here if I want to delete that key or pause or suspend that key. I can do that here as well. Coincidentally here, even though we haven't gotten to that point yet, I can assign identity policies for this user as well from the drop-down list, and we'll talk about those in a second. For that. So again, the keys here are going to be, we need to search for the user. Even if it's just a local user, we should go through and search for them, define the keys, again, the keys, up to 2 keys per user per tenant, and that's what we're going to have here. So once we have those keys established, or once those keys are defined, we can go through and put them into your favorite utility, whether that be CyberDuck or AWS or S3 or S5 CMD. For those, we can put those in there. And then we have access in here. So in this case here, I'm using the AWS command line here. So I want to go through and I want to list the bucket here. So I do an AWS S3 API is the command that gets used. I specify the profile that I put those keys into. I specify the endpoint URL that I'm accessing here. In this case, the endpoint URL is basically going to be your VIP pool. So didn't talk about the VIP pool setup here, but this is one of the VIP pools for this particular cluster. And I give it a list buckets command. And here I see the bucket that I have. It tells me who the owner is, tells me when it was created. And I can go through now and I can do reads and writes to that bucket as that user. So very simple to go through and list the contents. There's obviously nothing in the contents of that bucket. I'm going to go through and here copy a file called myfile.txt up into the bucket for this. And then I'm going to list the contents of that and I can copy it back down. So very basic. It's there. It's good.
Hey, Phil, we've got a
Yes.
few questions. Sorry to interrupt, coming in the chat. So our chat team wanted you to pause and just field a few of those before you keep moving.
Sure. Okay. Let me take a look at the questions here. Let's see here. So talking about user span, so the Q&A here. So user spans multiple tenants. So yeah, a user can span multiple tenants. And really with in terms of a user, So the question was, how is it that a user spans multiple tenants? So when we're talking about a user, when we establish multi-tenancy, we can establish each tenant has its own set of providers. A tenant can use the same provider. We're talking about a provider. We're talking about an Active Directory domain. I'm joined to an Active Directory domain, and then the tenant will use that Active Directory domain to define its users. Now, for those there, when I say the user can exist in multiple tenants, we're talking about the same Active Directory user is, from tenant one or tenant two or tenant three. They could also be different combinations of providers there. So the user exists in Active Directory, but has a different context in different tenants because they may have different rights, especially if we're talking about maybe different departments within the same company for those. So that's how a user can be part of multiple different tenants. Key replication. Yeah, so key replication across the clusters does not depend upon. So the question is, key replication across multiple clusters depends on the setting for enable bucket replication. That's not actually correct. The key replication between the clusters is established anyways. It does go through and replicate across for that. The enable bucket replication is a separate setting where if I already have, let's say if I'm replicating endpoints or I'm doing things like local namespace with those, it says that if I create a bucket on cluster A, automatically create the same bucket and views on the remote cluster. By default, with our replication, we replicate just the data and not any of the views or the bucket definitions there. Even if we're not replicating those views there, the keys are replicated across. So it's not actually dependent upon it. Yeah, so talking about bucket policy features, there's a retention definition. So there are lifecycle features there. We'll talk about those in a second. In terms of which is faster for files, looks like that one's been. Which one is faster for S3 or file? That's already been there. And then here, in regards to restricting access via IP, can this be done using the standard S3 commands API using a bucket policy like AWS? Yep. Yeah, that can also be done. The restricting based on IP can be done via bucket policy for those. I don't go into all the ins and outs and how to define the bucket policies. I'll touch on those in just a second, but we will follow as closely as we possibly can the same types of commands that you can use for that. So you can set in the bucket policies IP addresses there. So I think that covers all the questions for the moment. All right, so let's continue on here. All right, so let's talk about an S3 endpoint for how we go through and set this up. So an S3 endpoint is a little different than a bucket in the sense that an S3 endpoint is a special type of view that is a place where users can create their own buckets. So this would be an S3 API command to go through and say, I want to make a bucket. When we create an endpoint, we select here, we can have the same view policies that we use, but we select under protocols, we select an S3 endpoint for this. So it doesn't show up as a bucket. The endpoint itself doesn't show up in the bucket listing. It just means that when if I use the commands to create a bucket, they will be put under this path here. When we define an S3 endpoint, we need to go through and define which, or give some definition as to which endpoint this is to be used by, which users this is going to be used by. And that can be either specified by specifying individual users that are going to be using this endpoint, or specifying which groups are going to be using this endpoint. Now, when it comes down to specifying users and groups, the question comes up: well, can I have multiple endpoints with the same groups in all of those? You can, but it's kind of not undefined as to, if I issue a create bucket command, where will a bucket be created? Because it could match multiple places. So generally, it's not recommended to go through, and you can't select from the bucket create command which endpoint you want to go into there. So generally, it's recommended just to have users, have a single group in there that matches the appropriate users that you want to have there. Now, there is also here a specific action that has to be allowed for the user. This has to be defined via the identity policy, specifically in S3 create bucket ability, has to be defined within the identity policies for that user to allow them to be able to create buckets. Otherwise, they're going to be blocked from being able to do that. So S3 endpoints are relatively simple to go through and set up. We define those here. For that. Once those are set up and we give the person the appropriate ability, specifically that create bucket ability, we'll talk about how that gets set here in a second, but then we can use our standard S3 API commands here. So in this case here, we're going to use an AWS command, S3 API, the profile with the same keys that I defined before, create bucket. I want to create a bucket called pwags-bucket, and I define the endpoint that I'm creating this in. So on the cluster, the VIP pool, that endpoint exists, and it says, okay, hey, here's a bucket. And if I want to delete the bucket, I can delete the bucket there. I can list the bucket. I can do everything there. But that's how we make use of an S3 endpoint. Pretty straightforward, allows for users to create buckets as they need to. Moving on, let's talk about identity policies. How do we establish our identity policies? How do we deal with identity policies within VAST? So identity policies, if you're not familiar with those, identity policies and bucket policies, they're all kind of the same thing. They control, they're a set of statements that define permissions that either allow or deny actions to particular resources. And resources in this case are going to be buckets and or objects. For an identity policy is going to be attached to a user, one or more users, or one or more groups. And within that identity policy, it's going to identify what resources that user has the ability to go through and access. Identity policies are let you set the permissions for any of the supported actions that you want to go through and do. With that, and from here we do have a GUI that allows you to go through and define those there. We'll talk about that a little bit more in a second here. And then you also have an option called a bucket policy, where a bucket policy is something that is step back here. So an identity policy is something that's established by the cluster administrator, and the cluster administrator says, okay, these users have these policies attached to them. A bucket policy is a control that an owner of a bucket can go through and say who has the ability to access that particular bucket. So one of these can be an administrative action. The other one can be a user action to control access. And we'll talk about those here as we go. So an identity policy is generally formed like this, where we have the policies are going to be defined per tenant, again because we're going to have different buckets and different tenants there, but they're defined per tenant. They are defined in the context of a user within that particular tenant. For those, so they're composed generally like this. And I'm not going to go too much into detail about all the different types of actions and things there, but they're broken up generally in this kind of a format where you have a statement in here that has certain actions, and these actions can either be explicitly defined for this. We could also use wildcards for part of the actions here. So in this case here, I've got an action of S3 get, S3 head, S3 list. This S3 action of get asterisk means that anything that starts with get, so this could be get object or get buckets, any of those actions there, or head could be head list head, or list headers or things there. So we can wildcard those there. We can just put an asterisk in there, which gives them all the rights for those. This example here of head asterisk, get asterisk, and list asterisk is basically gives you read-only access to anything that is contained within the bucket here. There's an effect. An effect says, okay, for those actions, is that an allow effect, meaning I want to allow those actions or I want to deny those actions? And then we define the resource that this statement applies to. And the resource is going to be based on an S3 bucket name. So we have to identify an S3 bucket name and then the contents of that particular bucket. So in this example here, this is allowing access. This applies to S3, pwags-S3 is a bucket. And then this applies to certain objects within the bucket or certain objects with certain prefixes. It doesn't apply to all the objects in the bucket. it only applies to certain objects. If I wanted to have the bucket and the objects in the bucket, I would have a different statement in here that would look, excuse me, I would have a slightly different statement in here that would say pwag slash asterisk. Pwag slash s3 slash asterisk apply to every object in there. The syntax of here is going to follow AWS standards. AWS is basically the designer of the protocol. We're going to follow. So we do have a GUI based editor here, and I did point this out here that does allow you to do some editing here and select the types of actions you want for this and put those in. It'll generate the JSON for you. If you want to just go through and just copy and paste the JSON directly into the GUI editor, you can go ahead and do that. That's perfectly fine as well for establishing identity policies. So again, once we got the policy defined, then we need to attach that to the user. So much like generating S3 keys, we would go through and we would define these. We'd go through and define these. We'd have to search the user and attach the identity policy to the user from there. So in this case here, I search for my user and I want to attach one of the identity policies here called read write everywhere. For this, I just click on that and it attaches here. I've also got another identity policy assigned to my user called bblight-catalog, but then I would have access based on whatever those were. Now, bucket policies are going to be a little bit different for that. The bucket policies do have the same general syntax in terms of allows and denies here for this. The main difference here between a bucket policy and an identity policy is that identity policies are assigned by the administrator of the cluster. Bucket policies can be assigned by the user. The bucket policies also, rather than having the policy attached to a particular user, with bucket policies, you identify as part of the syntax of the bucket policy the principles that it applies to, whether this be individual users or whether this be individual groups. So here's an example of, again, a generic, just a general bucket policy here, where I have a bucket already created called pwags-bucket. The resource is this is going to allow someone to access the bucket itself as well as objects within the buckets. Here, the principle for this is going to be limited to just this one particular user. So vast user 1 is the only user that's going to be able to access this. However, I'm giving them full access to that bucket. So S3 : means all the S3 actions are allowed to this user. As a bucket owner, I can go through and I can apply this policy to the bucket using your standard AWS commands. So again, using the AWS API commands here, we go through and we use a command called put bucket policy. We identify the endpoint, the bucket I want this to apply to, and then the name of the JSON file that I want to use here. So I'm applying this bucket policy that I defined. It's in this file. I'm uploading that to that bucket. Once it's up there, I can go ahead, I can list that I can get that bucket policy back and see what's defined there for that, validate it's there. If there are errors in the JSON when I try to do the put bucket policy, I'll get an error back saying, yeah, there's something invalid with that invalid user things there. Now, the one difference here between the bucket policies and the identity policies as well is that from VMS itself does not have the ability to look at the bucket policies or manipulate the bucket policies directly for that. They're done strictly through S3 API calls. For that, there is no GUI-based editor for bucket policies. Lifecycle rules. So lifecycle rules, again, can be, lifecycle rules basically allow you the ability to automate or manage expiration of files or objects within the element store. So this example here, I'm talking about how we define the lifecycle rules through VMS. I'll talk about why you'd want to go through and do that. But you can also do this through the S3 API if you craft the appropriate thing. I don't have an example on setting those policies, those lifecycle rules using the S3 API specifically, but you can go through and do that using for S3 Magic. But for here, within lifecycle rules here, we can define this within the element store within the VMS GUI. This allows us to do things like, hey, I want to manage previous versions. So if I've got versioning turned on for my S3 bucket, and I only want to keep 2 versions of objects up there rather than every single version that ever gets uploaded. For that, I can set that. I can go here and control and say, hey, I want to keep only 2 versions of objects that are there. With S3, you also have multi-part uploads where chunks are uploaded up in separate pieces. Sometimes those uploads don't always complete. Maybe the client dies for that, but those multi-part uploads will stay until it's completed. This allows us the ability to go through and clean up those incomplete multi-part uploads, or just do general exploration of data after a certain time based on when it was last accessed or how old it is or the size or certain file names. Now, this runs at midnight UTC. This is the same thing that happens on AWS in terms of cleanup, so it runs the same way on VAST. Runs at midnight UTC every single day, and any files that are identified or objects that are identified for removal are removed immediately, and this is permanent. No different than if you did an explicit delete of that. Now, permanent meaning that, okay, maybe we don't have snapshots set up or data protection set up there to go through and keep the objects there. But here it doesn't go into a trash folder for that, but it is immediate and permanent. Now, the interesting thing about the lifecycle rules is that even though it's mostly used with S3, it is something that does apply to all of the other protocols as well. So if I want to go through and use S3 lifecycle or use lifecycle rules on, let's say, a scratch space that's only an NFS export, we can use those same rules and apply to that. So it's not just only S3 can be used for other types of file systems as well. Again, just some other views on things there, that lifecycle screen in terms of some of the objects here for this, and this is you have options to say again what the prefix of the object is. We want to look at certain objects. Only want to consider things of certain sizes. Only expire the current versions or older versions for this. We can set all of those there. This is set based on a particular view, so it's not I want to get everything within the element store. It's only going to relate to a particular view. And again, that view doesn't have to be just S3. It could be NFS, could be SMB, any one of those there. So another option here. All right, so last portion here, let's talk about multi-protocol considerations. So as I mentioned, VAST is multi-protocol. We are designed to be multi-protocol from the get-go for this. The data is stored in independent format, a protocol independent format, and we define via the security flavors how we want to go through and control those protocols, or how we want to control those access. And that allows us some pretty interesting flexibility, which it gives us some options here. So when we go through and we define our views, again, we define our security flavor. Now, the vast security flavors that we have are NFS, SMB, S3 native, and mix/twins. And these are all slightly different permissioning models. NFS is going to be your typical POSIX mode bits. SMB is going to be your NTFS style ACLs with more granular inheritance. Mix/twins is going to be your NFS v4 style ACLs. And then S3 native is identity policies and S3 style ACLs. Now, we can use these different security flavors, and we can set those independent of the protocol. So I can do things like I can have my S3 access govern, apply that, use S3 access for existing data sets and have my access control governed by NFS mode bits or SMB ACLs rather than identity policies for that. Just a matter on with my existing views. I just enable S3 as the protocol. Again, keeping in mind that I have to set a bucket owner there, and that'll change the owner of the directory. But I can still control, use S3, and my access is going to be the same over NFS as it is over SMB or as it is over S3, and permissions will be controlled from NFS or SMB as appropriate. What also is interesting here is that we can completely eschew the traditional POSIX mode bits or ACLs and use S3 identity policies or even S3 bucket policies to govern how we access things over NFS or over SMB. Now, when we're talking about accessing data, using or controlling access for using identity policies and bucket policies there, we need to be a little bit aware as to how things map between those, what types of actions on the S3 side, how those map to RPC calls or how they map to SMB calls for that. We do have information in the documentation as to how, like, let's say a head object or a put object or a get object command maps to the NFS RPC call. We do have tables in there in the documentation as to how those map. But generally, if you just simply think about things, hey, I want to have a read-only file system, with the identity policy, I have a read-only bucket policy where it's going to be all the S3 get commands, all the S3 head commands, all the S3 list commands. That will apply to the same kind of access for SMB or NFS. Now, the one thing to be aware of, though, is that when we're looking at those cross-protocol situations where your permissions are going to be controlled by an S3 identity policy or an S3 bucket policy, you're not going to be able to see those permission models reflected over NFS or over SMB. When I say reflected, means that if I do an ls minus L, it may look like I have no permissions to access a file. I'll see it's owned by somebody else and permissions are zeros for group and other, or I look at SMB and it says it's owned by somebody and there's no ACLs there. You'll still be able to get access if the policy allows for it, or the identity policy allows for it, or the bucket policy allows for it. You just won't be able to see those permissions there. So it does take some user education just to, either you do have access to it, you're just not going to be able to see it, but it does allow us for some other interesting setups where, again, we can use identity policies to control access such that so that we don't have to go through, and when a new group needs access to data, I don't have to go through and run a recursive ACL change or a recursive chmod against my data set. I can just put them in the identity policy or attach the identity policy to their user or their group, and they'll have access to it. So some other possible options here. So with that, that's kind of a quick whirlwind of the basic setup of S3 for that. Hopefully you found this useful. And with that, let's see if we have any other questions here, and we can wrap up there. Let's see. So I don't see any other questions here other than the initial ones. Let's see. Can we share documentation for the RPC access across protocols? Yes. So this is in the vast documentation that's out there. So if you go out to our support site, go to vast.com. There's product documentation, product support. These are going to be listed. It's in the S3 access guides. There is a key that you want to search for that makes things kind of easy to go through and do. There's an option where let me share my screen here, so I'm pointing this out here. If you search for the term specifically controlling file and directory permission or directory permissions across protocols, that's the key that will give you the listing on. It will basically give you this table here. This I just showed the NFS RPC mapping, just a portion of that, but we also have one for SMB as well as NFS v4. So searching for that controlling file and directory permissions across protocols is what you're looking for to get those tables. So question on, does an NFS client side programs get confused by overlaying an S3 policy on NFS? So when it comes down to how an NFS client interacts with these kinds of things, it depends upon what the behavior is of that. With NFS specifically, if we have, this also applies to if we're using an SMB flavor, security flavor. With our security flavors, there's rules around which protocols can. Not only you're limited to what kind of permissions you can set, but which protocols are allowed to set permissions and set ownership and things like that. So, does a NFS client program get confused by seeing permissions that it can't necessarily access things? The answer to that is, well, it will if it checks, if it goes through and looks at the permission before it actually tries to go through and do the access, yes, it will see there's not permissions. It might throw an error based on that. But if it just goes through and just tries the access, tries to create the file, that'll succeed. So it depends on whether it looks at the permissions or not. There is a option within the view policy. Might be within the view, but within the view policy or the view, there's an option that can be set called return open permissions that will basically show the permissions that are displayed as completely open, meaning 777 for NFS. So if a program actually looks at the permissions before attempting an operation rather than just attempting the operation and either getting the succeed or denied, this would show the permissions as being completely open. But generally for those there, it doesn't. We don't see much of a problem with programs or things there. It's more if someone or the program tries to look at the permissions, tries to make sense of them, rather than just saying, yeah, they're there, just create your files or not create your files. I think that covers all of them.
All right. Well, while you do a last check, Phil, I will just make sure everyone's aware. We have our first user conference coming up in February. So it's February 24th through 26th in Salt Lake City. You all are cordially invited to attend. We are going to have admin certification there, as well as training and hands-on labs. It's going to be a great event. And so please, get the permission that you need on your side and register for that event. We would love to see you there. I also have put a link in the chat for a PDF of Phil's slides for today so that you can have those to take with you. We will send out an email with the recording. We also have our upcoming webinar that we are doing. And so next month, we are going to dive deep into the new 5.4 release from VAST. So give you the what's new on that, and then also even do a sneak peek as far as 5.5. So I just you put it in the Q&A section instead of in the chat because I was over there. So here is a link, and it will also be in that email for you to be able to register for that next webinar. So Phil's left the stage. I think that means we've answered all the questions. So thank you all for joining us, and we'll look forward to seeing you next month for our next customer training webinar. Take care, everyone.